This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber. My guest today is David. He's one of the founder of Limitless CNC and is based in Tel Aviv. Shalom, David.
Hi, Robert.
Hi, David. Welcome. We already spoke on the phone a few months ago. At the time, you had just returned from your military service and were in the process of setting up your company. Last week, you went live. Congratulations. You raised more than $4 million. $4 million, sorry. How does it feel?
It feels very exciting, I have to say.
A bit of pressure?
Yes, and a lot of excitement around it. I guess, establishing the company and recruiting all the crew and everything happened obviously before, and things got on track really well. But once you go out live, I guess it adds another layer of excitement to it. So yeah, but thank you for having me here, and it's going to be great.
We're very proud to have you with us because it's your first interview when it comes to Limitless CNN, right?
That's right, yes.
Perfect. Before we start talking about your company and CNC, please introduce yourself briefly to the listeners. What is your background?
Cool. So I'm a mechanical engineer in my background. From Israel, I studied at the Technion. And after that, I joined the army as part of academic reserve. So I joined the technological unit in the intelligence corps, where I spent 8 years. I have to say that this is the place where I studied all my knowledge and experience in the world of mechanical design as well as manufacturing. And after that, I left the service as a major ranked and joined an early stage startup in the world of last mile fulfillment. Automation centers involve a lot of robotics development, computer vision, all that stuff. And guess when the war started in Israel? It was my wake-up call, you can call it that way, where I find myself again in duty reserve, helping a lot of combat units, developing quick technological solutions that involve a lot of CNC production. And I found myself running again between CNC machines in different production sites in Israel. And this is where I saw with my own eyes the crisis that this industry is living for a long time. And in critical time like this, where you need to produce accurate parts really fast and you don't have a lot of time to iterate, this is where you see the need and demand for innovation and technology. And this is how the idea of Limitless CNC came to life.
We had the guys from Sunfake on the podcast, I think 2 weeks ago, and it feels like we are becoming CNC AI podcast. Why is there so much going on in the CNC area?
Yes, I have to say that the timing was very interesting. I listened to this episode where Mr. Islam from Sunweek shared their effort in the world of AI and CNC. And I have to say that for me, this is very exciting times, because I think it makes sense like in several aspects. So first of all, let's start with the geopolitic timings. So a lot of Western countries realize that they cannot continue to outsource and rely solely on critical components manufacturing outside the country. So they understand they need to bring it back, because in critical times, as war, for example, you understand how important it is to have an independency in producing critical component parts. So you have that awareness, and you can also add it to the, let's call it, the general buzz around AI, which I think with the ChatGPT and in general, all the LLMs technology that is like penetrated into every aspect of our daily life, right? So everyone now are aware of what is our agents and what AI can do for you.
Are you sure that everybody? I think not everybody, because there are so many different definitions when it comes to agents and AI agents.
I totally agree with you about the definitions, but I guess you can stop any person on the street and ask them, are they familiar with ChatGPT? And the answer probably would be yes.
Maybe in Israel, not in Germany. Yeah, but yeah, yeah.
And lastly, I think in terms of technology, we are in very interesting times where AI and 3D is coming from academy into the industry, right? And this is a natural movement for a lot of type of technologies that start with academy, with researchers, and then when it's mature enough, you start to see implementation in the industry. And I think 2025 will be the year where we will see like real type of solutions around 3D and AI, and
So
Limitless is
physical
part of
AI.
it. Physical, and not only physical, but also physics that involve 3D inputs.
Your company name, Limitless CNC, is very ambitious. Limitless. Yeah. What do you do?
So we are developing AI agents
Mm-hmm.
for different CNC applications. First of all, starting with the most critical stage of coming up with a production program for CNC machines. This is our core technology.
So coding, right?
In a way, you can call CNC machining or programming a coding aspect, but like today, CAM programmers, this is the name of the profession, are working with CAM solutions by companies like Sandvik or Siemens or the Sol system. Yeah. And basically, those tools allow them to come up with different tool paths and operations and tool selection to come up with a production program. Limitless is developing an AI agent that is integrated into those tools. So it's not trying to replace those tools. Instead, it integrates into those tools and is serving the user as a smart assistant, but not in searching for documentations with LLM models. Instead, we are helping the user in the critical mission of coming up with an optimized CNC program. So basically, our
So
technology.
it's an optimization agent.
Yes, it's an optimization agent that is operating as a recommendation engine. So basically, it's like playing chess with an assistant that tells you what tool to pick at every move and what movement to create.
Mm-hmm.
This is how it works. It's not involving any LLM under the hood.
So it's not
It's
a Gen AI approach.
Well, GenAI is a broad description for AI that can generate outputs based on your inputs. So you can call it Gen AI, but I think call it an LLM is not understanding the technology. So because the input is not text, is 3D files, which are far from being text input.
Can you take a look under the hood with us? What kind of model do you use? What happens when the user is interacting with your agent?
Yes, of course. So as I mentioned, because it's a recommendation engine, so it analyzes the current state of the process, including the state of the working piece material, the state of the environment, what machine you use, what fixture you used for this machine, what are the available tools you have. And then it analyzes these inputs and come up with a suggestion for the next best step to create within the CAM programming session, including what type of operation to choose, what type of tool to choose, what are the right feeds and speed and different parameters to set to have an optimized operation. And once the user is willing to accept this recommendation, he only need to click one button and then we generate for him this operation inside his native CAM environment as if a human did that.
But how did you train the model?
That's a great question, and that's the secret sauce, I guess.
Yeah, you have to unveil this here.
Yeah, try to keep it reasonable
You
enough.
can go into details. We want to hear everything.
I'm sure. So it relies on several silos. So, first of all, we are using reinforcement learning techniques with physical modeling of the problem. So, we developed our own physical engine that is based on different physical phenomena in the process of CNC machining, like the forces that are produced on the cutting tool, the deformation of the cutting tool in terms of bending, the load on the spindle, the load on the fixture, like a lot of different phenomena. And this engine allows the AI to train itself, to come up with different decisions and receive a score for these decisions that allow the AI to improve. But this is not the only approach that we use. So we have a combination of this approach, also leveraging our clients' data. So basically,
So you already had clients with data.
yes,
Okay.
yes. And it's obvious to mention that in the manufacturing world, the data is a very sensitive IP for sure. So our approach is to build a custom AI version for each client to serve this client solely and exclusively, also protecting their data so their data is not mixed or shared with other clients'
So it's
data.
a federated learning approach, or what is it?
So we take their CAD and CAM data, we run it through our system, we filter it and also score it in a way that we can split between the good decisions and the bad decisions. Because one of the problems in the industry that you have expert, that's right, but most of the industry are far from being expert. And you really need to sort that data before you train the AI, because otherwise you're gonna train also on not that good approaches.
Mm-hmm.
So basically, we are able to, let's say, learn the best practices of our clients and implement them into the AI. So, for example, if they usually use a specific cutting tool for a specific operation in a specific environment set, so we can mimic that in a way, and also allowing our own improvements based on our physical engine to be incorporated into this AI model. So it's a mix of two.
Can you go a little bit deeper in this physical engine? What is it, a physical engine?
Well, basically, a physical engine in general is something that receives an input. For example, the geometry state of the working piece material and different parameters on the machine and the cutting tool and the material type. And it can calculate a lot of different equations and sometimes not only equations, but also run some neural networks that can estimate different phenomena. For example, there are like very straightforward phenomena that you can estimate roughly with a simple equations. For example, the spindle load in terms of power, right? You don't need a neural network for that. But when it comes to complicated phenomena like the deformation of an undefined geometry
Mm-hmm.
under a specific force regime. So this is something that usually requires a finite elements analysis approach by tools like ANSYS, right?
Mm-hmm.
But the thing is, if we're gonna integrate an ANSYS analysis for each iteration, we will bankrupt with the computing cost as well as we will lose all the clients because the time is long. So there's a new approach in the industry, and I'm sure that you heard about it, which call PINs.
Mm-hmm.
So physics inform neural networks. If you want, I can elaborate on this.
Yeah, sure.
Bit.
Yeah, please.
So basically, PINs are a way of using neural networks for physics analysis scenarios. It's very common for CFD analysis.
And DEMS, discrete element method too.
Exactly. And the main advantage of this approach is the ability to run a very lightweight analysis that does not require you to run a full mesh on the body and calculate discretely every junction in the mesh. Instead, you train an AI neural network on a lot of simulation results. Hopefully, you come up with the right data set for those simulation. Like this is the critical part. And once the AI saw enough simulation results of different geometries,
It
it
learned
can come up
the
with
physics. Yeah.
yes, exactly. It can come up with an estimation of how a new geometry that you input into this network will behave in terms of deformation. So this is part of the technology that we use for this physical engine. Obviously, as long as you keep growing the data set and running more information through it, and also check this information with real tests and real laboratory environment and real clients environment, it will improve.
So the model learns with each application, right?
Yes, yes.
And if the operator changes something in the suggestion by the model, it will also learn, right?
Yes, this is the beauty of working as a recommendation engine for one step at a time. So you have a lot of feedback from the user.
Are you only cloud-based, or is there also an on-premise solution for that?
So currently we're running on cloud and we're developing our entire solution on cloud. But we already have some large clients that are working with us towards an on-prem version. So they have their on-prem environment and we're gonna deploy our solution into their on-prem environment. So yeah, we understand that the necessity for on-prem solution in our industry. One of the most demanding industries in this field is the defense and aerospace, and they're not allowed to work with the native cloud, let's call it that way. And obviously they're very interested in this type of solution and they're willing to do the leap of faith to try the on-prem version. So yeah, we are putting a lot of effort to establish this type of solution.
As you mentioned before, C&C is a big playing field, right? Siemens, Sandvik, all the others. Do you integrate your solution, your agent, to their software, or what is your approach?
Yes, so we are integrated currently to Siemens NX, which is one of the leading solutions in CAD and CAM in our industry. And we're also working on integration into additional CAM solutions. The idea is that we're not trying to educate users to try a new CAM tool. More than that, I think that CAM tools are great tools. Like they've been developed for years and they have so much technology in them and they're so stable and well familiar. So it just doesn't make sense to try to replace it. Instead, what we're trying to add to the picture is the knowledge of how to operate those tools.
Exactly. What are your next steps to integrate the solution in more the software applications? Is it to add more functionality or to fulfill the first customer wishes? What are your next steps?
So, for startup, we don't have the privilege to take our time. So we need to move fast, especially because we understand that we are operating in a very tight opportunity window because we know that everyone is working on this type of technology because it makes sense, right? To bring AI into this world, and there's a real pain of lack of knowledge and skill gap in this world. So we're putting our effort first of all to make our customers happy and
What is the
working.
competition like? Is it the big players or who is your competitor?
So it's a combination of the big players and some startups like us.
Mhm.
The competition is international. There's companies in Europe, in the US, in Israel. So
And your go-to-market strategy is to sell license to Siemens and X, or is it to work directly with the customers?
so we work directly with our customers. Obviously, everything is established by working with Siemens, like we are an official business partner with them, like every other company that provides solution on top of their API. So yeah, we sell directly to our customers basically because we offering a custom AI solution for each company. This is requires us to work closely with each client, and it's a subscription based model. And our focus is actually, and maybe this is something that is a bit different from other companies, we are focusing on OEM companies that have their own production lines and own product lines, and they deal with a lot of variation that coming up from their clients demanding different custom designs for their catalog products, and then they need to deal with a lot of variation programming, something that simple automation tools that already exist in CAM softwares are not even near to solve. So they need like heavy type of solution in terms of technology to come up with smart automation for these type of variations. So this is our focus. We already have large customers in Israel and Europe,
Mhm.
and we're currently working on important deal also in the US.
Why didn't you ever try, or maybe you tried, using an LLM? Is this an inference topic, or is it a general decision not to run a LLM in a CNC environment? Why didn't you try an LLM?
So that's a great question. And this is something that we tested pretty early in our discovery journey. So the idea around LLMs is that they work really good with text, right? And the thing is, you can try to implement LLMs on text in relation to CNC by giving an LLM G codes. G codes are basically the compiled language in which the CNC controllers are reading commands and execute them as robotics movement. The problem is that G code has no any reference to a 3D geometry in a very straightforward way. So basically, by reading G code, it's really hard to understand the geometry of the part. And add to that problem also that G codes are like human languages. Like they all have the same type of sentences, the same type of words, but different languages. Like each machine has its own small variations of G code. So it's making it even harder to train an AI LLM on this. I'm not saying that it's impossible. I'm just saying that it doesn't make sense for us to
And it's
try.
an inference topic, right? So it's not very cost efficient.
This is another aspect as well. Yes, you're right. But I think that once we see a breakthrough in this field of CNC and 3D, hopefully it will be limitless. But once we see this breakthrough, I don't think it's going to come from LLM. It's going to come from different models that are more suitable for working with 3D inputs.
Where can meet you in Europe? What are the next steps? Which trade shows you want to attend?
So we just came back from a trade show at Chicago actually
Okay,
last week.
yeah, sure. ProMat, right?
The American Manufacturing Summit was great, and we're planning to attend two events by Siemens in Detroit and in Amsterdam called Realize. So we're going to be there as well, and we're planning to add some more conferences as well. So hope to meet people there.
Yeah, absolutely. We are really looking forward to meet you in Europe to see more. Can I order a demo at your website, or is it possible?
Yes, it is possible. Our website is live from last week, so yeah, totally.
David, it is very impressive what you invented in this short time in Israel when it comes to CNC, limitless CNC. It was a pleasure to talk to you. Thank you very much, and all the best for you and your team and your approach.
Thank you very much, Robert, for having me.
You're welcome.